So this is the underwater system, today's topic. And it is about chapter 7 of the second textbook. And first part will cover the history and also the manned underwater system. And second part will be about unmanned system. Right? So this is the history. How many years ago? 500 years ago. Is that right? Right. Guglielmo from Italy developed a diving bell. The picture is in left-hand side, first one. And the shape looks like a bell, real bell. So that's why they use a diving bell. And after 100 years, Naval has developed a submarine, first submarine. Probably man-powered submarine. In early 1700, another person from England developed a diving chamber. Probably this is different from diving bell. Probably as a pressurized chamber. Chamber means a closed room, rather than diving bell is open. In bottom part is open to the sea. So that the difference is that the pressure inside the room, because the diving bell is open in the bottom side, no closure. The pressure at the water level is same as the pressure inside the bell. The air pressure is going up as the bell position is going down and down, because every 10 meters of water, the pressure goes 1 atm plus, right? So say 100 meters of depth, then we can expect 11 atm pressure, very high pressure. That's why you usually are saying that 30 or 40 meters is the limitation for regular people to sustain the pressure. All right, in 1776, Bushnell from US invented a hand-powered submarine, probably in the right-hand side and picture with a red-colored shirts. And then 1800, so Fulton from US, or also hand-powered submarine, another one. Probably bottom one in the left side, I don't know, I'm not sure. And then 1866, there is a first automatic torpedo. In 1906, the U-boat from Germany was developed. So U-boat was very famous during the World War II, right? But this one is already available in World War I, before the World War I. 1915 and 1945, that is during the World War I and World War II, major advances in undersea technology, especially submarines and also communication for submarines, took place during World Wars I and II, because submarine is very important for the battle. In 1934, Bessie Pier. This is for deep water exploration. So deep water exploration submersibles, chamber. Okay, and then for the further development, 1942. A person from France, Gusto, developed SCUBA. SCUBA is a short name of self-contained underwater breathing apparatus. Right-hand side, you see the image that is very popular to many people. In 1954, first nuclear submarine was launched in the United States. And I know that this is the first application of nuclear power to non-nuclear bombing. Okay. So it's another application in addition to explosion of nuclear power. And then after that, they started to build a nuclear power plant, because this application is very similar to nuclear power plant. Submarine propulsion as an engine, steam engine. And in 1960, there are also many subsea research, including submersibles and ROVs, and then also habitat. Habitat is apartment, underwater apartment, house. And further, in 1970, diving system. This is a deep pressurized, very similar to the space shuttle suit. The space inside the space, the astronauts wear such a suit, but the pressure is reversed. Right? In deep water, water pressure is very high, but in space, outside the pressure is very low. But anyway, this kind of suit protect the person inside to maintain the normal pressure on the surface of Earth. 1980, there has been a development of AUB. The specialty is no cable, the tether, no cable from the ship. In 1990s, commercial AUB, and then also gliders. Gliders are usually in air, space, but there is also underwater gliders developed there. We'll see the details in a later stage. So first part is manned underwater system. And manned system is classified into two parts. One is atmospheric pressure. That is regular, traditional, normal pressure, 1 atm. Same as the Earth's surface. But ambient pressure is going up because the surroundings has higher pressure as we going down and down into the deep sea. So ambient pressure first, we will see that scuba diving, the pressure to skin of the diver is going up, including pressure to, say, ear and also other parts, so that, and chest too. So as I told you before, that the practical limitation is about 40 meters something for normal person for the scuba diving. And diving bell also, it is open to water at the bottom side, so that pressure is going up as the bell goes down, so that there also a very high pressure inside the bell. So ambient pressure. And diver propulsion vehicle. So scuba diver may have a small engine to have a propeller. So you may, I don't know, but I saw that 007 film, James Bond film, there was I don't know, the series number 5 or 6. There is such a type of propulsion vehicle was shown at that time. It was about 20 years ago, so that at that time it was very fancy technology. Left-hand side, atmospheric pressure, submarine, submersible, bathysphere, atmospheric suit, and underwater habitat. Right, long volumes and capacities. So human body, you see at the left-hand side, 6,000 cc or milliliter is the capacity of the lung of human. But you see that the tradition in normal breathing, the tidal volume is very small, between 2,500 and 3,000. So only 500, 500. So 10% of lung capacity is used for normal breathing. But sometimes we need big breathing. So, but still 20% or 15% is not used. That is a residual volume something. So deep diving usually 12 meters or 40 feet. There is a recreational diving limit. And 30 meters, that is recommended recreational diving limitation, because there can be a nitrogen narcosis symptoms. We'll see more on later stage. And then 65 meters, that is a compressed air diving limit something, because of the oxygen toxicity is starting. And also there are other further depth, something like 155. There is a record depth for scuba diver, very special person. And then 700, there is a saturation diving, special device. Right. So diving hazard is something like this one. The three main problems is a carbon dioxide. This is because of the deficit of oxygen. Right? This causes discomfort, dizziness, and also oxygen shortage. So oxygen shortage and carbon dioxide excess is coming together usually, but sometimes they can be separated. So that brain will be damaged if oxygen is completely cut off for 3 or 5 minutes. So that this is, you can see that this is a limit of your breath stopping. When some people is problem of breathing inside the water or above the water, sometimes they stopped breathing. So then after 4 minutes, you may expect the brain can be damaged. So you need to somehow breathe him or provide oxygen to the person before 5 minutes. Oxygen poisoning, this is because of too much oxygen. 100% oxygen is not good. Also high pressure, because we see from this the bottom of this table, there is a saturation diving. They use this kind of special 100% oxygen with high pressure. So it is very special device and dangerous, but sometimes it is necessary. And so there is a type of breathing equipment. We need to have a regulator because the pressure inside the tank is very high pressure, so that the pressure is normalized by using regulator. And then the other three is how do you circulate the breathe air, because inside the water there is no air. So open circuit, maybe the air is released from to the ocean, but there is also closed circuit type, so that the air is reused by mixing more probably the oxygen something. And semi-closed is in between. And another diving hazard is the decompression sickness. That is a typical problem coming with the divers, deep divers. And because the pressure is high inside the human body, the blood has more gas inside. So it's a liquefied air is inside the blood. It's very small, similar to you may expect the Coca-Cola something, the drinking sodas. So when you open the bottle cap, then the gas is coming from the liquid outside to the air, because the pressure was high when it is bottled, so that the more gases are inside the drink. But once the bottle opens, the pressure is released, so lower down suddenly, so that gases that was melted inside the water is released. The same phenomena. So in deep water, the pressure outside pressure is high, so that there are more gases melt into the blood. But if you go upward toward the surface, then the gas is coming out. Bubbles are coming out from the blood. That causes your problem, sickness. That is very damaging to tissues. And so you need to have slow down the coming out from the deep water. So there is a limitation of speed going up from deep water. So it takes a long time. If once you dive into, say, 40 meters or 50 meters, you need to slow motion toward the upward. Otherwise, you can have this kind of problems. Also, the nitrogen narcosis, this is because also pressure, so that nitrogen is inside the blood. So for these two problems, only treatment is decompression. Decompression is you need to be, once the problem is happen, you need to look into the pressure chamber, so that you also treated by a high pressure, so that the bubbles can be melt again into the blood. And after then you may release the pressure very slowly, returning back to the normal pressure. Right? So saturation diving, this is diving bell. You see that this is a modern diving bell. So there is a door at the bottom. So the inside the diving bell, there is a depressurized. So the pressure inside the bell is normal pressure. It is same as pressurized room inside submarines too. So there should be another small room. Their pressure is changing from normal pressure to the outside pressure. So it takes also time to compress the pressure in slow motion. And submarines. Jangbogo class is Korean. Korean Navy is now developing 3,000 ton Jangbogo class 3. Oh, there is a Sononil class. That is also second class of Korean Navy. It is 1,800, but now is Jangbogo 3 class is 3,000 ton. Typhoon is from Russia. And right-hand side and bottom of the right-hand side, you see that Typhoon. And this is the largest, very similar to the Ohio class of United States. And you will see that those two are nuclear submarines. And the ton size is about 50,000, very big ones. And difference between nuclear power and diesel power in submarines. Here is the problem in diesel is that diesel engine is used for propel, but the main reason for diesel is to charge the electrical storage batteries, because the batteries are used to propel the submarine when it is submerged. So when the batteries are out, all used, then the diesel should be, the diesel engine should be started. But for the diesel engine, you need the air, so that submarine should be surfaced. Then the problem is the enemy vessel can find out where are you, the submarine. So that's why the nuclear submarines is better than diesel submarines. So here is a nuclear submarines. Nuclear submarine can divide deep, but it is not so important, the deepness, the depth of the operation. But more important is 60,000 nautical miles. That can be about how many? 80 or 90,000 kilometers before change in the nuclear fuel supplies, refueling. So you can imagine that 90,000 kilometers is probably how many? 10 times, probably 10 times, more than 10 times surrounding the Earth, circular Earth. So it is very long distance. But they can stay this long travel only once the power is mentioned. But the problem is other things. The most critical problem is coming from human bodies, human brain, because too many days underwater, they can have mental problems. So there is a rule so that the somebody cannot stay underwater probably 1 month. I don't have the number. So anyway, there is a regulation to any national navy. All right, we can see the video.
A submarine has a sleek cigar-shaped body that enables it to move swiftly underwater. A pressure hull made of high-strength metal contains the submarine's crew, machinery, and most or all weapons, preventing them from being crushed by the pressure of the water at deep depth. A submarine has tanks built into the bow and stern called the main ballast tanks. The sections of the bow and stern containing the tanks are not usually surrounded by a pressure hull. In order for the submarine to dive, the main ballast tanks are flooded with seawater. The added weight causes the ship to lose its ability to stay on the surface of the water, and it submerges. Movable surfaces on the outside of the submarine control its movement beneath the water. These surfaces are horizontal diving planes and vertical rudders at the stern, and a forward set of diving planes either on the bow or on the sail structure. To dive, the diving planes at the stern are tilted down. As the submarine is propelled forward, the flow of water over the tilted planes causes the submarine to glide downward. The rudders steer the ship. Crewmen can turn a rudder to the left or right to make the submarine change course. To move the submarine upward, the stern diving planes are angled up. The diving planes at the bow or sail are used to help keep the submarine at a precise depth while near the surface, especially when launching missiles or when raising an antenna or periscope above the surface. To resurface, water is blown out of the ballast tanks by compressed air so that the submarine comes up through the water.
Okay. All right, so here is some examples of non-military submarines, mostly for sightseeing and shore, near shore. And also there is a research submersibles that is trying to research of deep water. So it is non-military submarines with a limited service range, because military submarine, as you see from nuclear submarine, the service range is very important because of the enemy. And then the submersibles has a mothership, so that the transportation is done by the mothership or surface vessel or other submarines. So this one, the right-hand side, saying that this is from Japan. It's saying that Shinkai 6500. That means these submersibles can dive into the depths of 6,500 meters. So it's very deep water. That is for research submersibles purpose. All right, that's it. Questions? No questions. Then we can go on to discussion session led by. Well, there is one chatting. Indonesian submarine sinked. Was the high pressure in the ocean depths the reason for that? No, usually the problem, the reason for sink is failure of the operation, the engine power or control something. Something is wrong with that control. And once that, say, your energy is up, no more energy, then usually you don't have power to reboot submersibles over the surface. That is the reason. Because you see, usually inside the water, when they operate, the, how can I say, the buoyancy force is a little bit lower than the weight. And then the remaining weight or buoyancy, that is operated by, supported by the wings. It is the usual way to operate. So once sometimes suddenly you lose the operation or power, propelling power, the total buoyancy is a little bit lower than the weight. That is the usual way of operation. So that submarine is slowly going down. That is the usual operation. So that is the problem. And then once it is going down deep water more than the design depth, then after that it can collapse. That is a usual way of failure of submarines. But there can be another reason, something like explosion during operation, something. But that is very rare. So most problem can be the power loss or control loss. All right, let's go on to discussion session, please. Something.
Do you see my screen?
Yeah. Well, you can, well, yeah, that's enough. That's good.
Today's discussion session topic is underwater systems. The first topic is unmanned underwater vehicle. As you know, where UUV are divided into two major parts. Remotely operated vehicle, it is ROV, and autonomous underwater vehicle, it is AUV. Right side, you can see the ROV is upper side, and bottom figure is the AUV. ROV is remotely operated, and it could go inside the sea or ocean, but it is need to connect the ship and the surface with unique cables. They are connected. This cable act intermediate between ROV and ship operator. Next is the AUV. It is self-powered and guided vehicle. AUVs are trending vehicle in recent time for ocean-based study. Compared to the ROV, AUV don't have cable or remote. They do nesting, detecting, and removing obstruction without any human operator. It is fully operated, automated. Once they are done with the survey and collecting information, they are back to surface where their data is collected and stored in the systems. So first discussion topic is like as follows. In the ocean industry, what is the role of AUV and ROV, and in what form are they likely to develop in the future? And second topic is what are the advantages of applying AI technology to AUV or ROV? Please suggest any opinion. Yeah.
I think in the offshore industry, AUV and ROV can be used to explore the ocean depth or to check the feasibility feasibility of any offshore for any offshore projects. So yeah, so they can be used to explore the feasibility of any offshore projects. And regarding the advantages of employing AI, like as far as I understand, like even like for an ROV or AUV, there needs to be a controller somewhere outside. Yeah, sorry, for ROV, there needs to be a controller who's controlling the ship manually. I think AI can help to maneuver autonomously, and other than that, I think AI technology can also help in control. So, for example, if the ocean water is very turbulent, it might be difficult for the controller to control the AUV or ROV precisely. So AI technology can use sensor information to make it much more easier for the AUV or ROV to traverse the water.
Songmin, you need to turn on your microphone.
Yes. Is there any other opinion?
I think that the AUV and ROV for the offshore industry can replace the human diver. They can do things the human diver do on the water, such as checking the system and doing a welding on the water, such that things, and to putting our AI technology to AUV or ROV is helpful for AUV, but I don't think it is not that helpful for ROV because the ROV is controlled by the human, and current days AI technology is less effective than human controlling. So the putting AI technology on ROV is not that effective in these days.
Yeah, okay. So I think the offshore industry usually mostly AOV and ROV used for oil in oil and gas industry. So to inspect the world undersea world for inspection of availability of gas and oil, AOV and ROV can be used, and I think they are obviously mostly being used, especially ROV. But with the recent advent of AI technology, maybe the application of AOV becomes widely available. So ROV is controlled remotely and using, as you have mentioned, using maybe wires to connect to the remote controller. That may inhibit how deep to the water can ROV be operated. So we cannot go below some distance because there can be like difficulties to communicate with ROV when it goes down, but to navigate autonomously under the sea, AUV can be used. But nowadays I don't think it's available to fully replace ROVs because, as Kyung has mentioned, it's not current AI technology is not as advanced as the human beings. So I think it will take some time, but after some time it will replace ROVs.
I heard about the article about AUV and RV. The contents was that most of RV has robot arm and most of AUV doesn't. So, and then because of that, the ROV is usually used for watching, and the ROV is used for just do something in the deep water, and AUV is usually to watching in deep water. So, if the case of I think ROV is just human can do something by their controller. It is, I think there is no content to help with by AIs. It is very not so big advantage, but case of AUV, I think AI technology can help to change the route or can help to change routes for a better route or find something important by using AI is possible.
I also wanted to add one more point. So, yes, like an ROV is controlled by a human operator, but I think AI will be advantageous even for ROV, not only for navigation, but also to automate processes. So, for example, if an ROV needs to weld, it can use AI technology to detect objects and it can make it easier for a human operator to easily do the process. So instead of manually controlling the arm, the human operator can choose an object and maybe with a click of a button can initiate the welding process. So I think features like that will be very beneficial. Will be beneficial for the human operator, and AI technology can help with that.
Yes. The next topic is the military application of UUV. AUV military applications will expand. Modern army, modern army, and they more and more use this kind of autonomous device that provide you opportunity or allow us to solve some problems without people. The UV can be called for ladies, the same as UAV. UAV means unmanned aerial vehicle. It becomes. The USA have been developing AUV for firing test, hydroacoustic and electronic resonance, and second, detecting of marine submarines and naval mines and other objects, and destroying them using torpedoes. That is the array missile carried by the AUV. Third, setting naval mines, sensors, and communications. Fourth, and finally, provide communication between devices for detecting submarines and command centers on ships or on shore. I prepared some video about the application of unmanned underwater vehicle. Can you hear the sound?
사운드가 안 들립니다.
Yes.
그 저기 쉐어링을 스탑하고 다시 쉐어링하면서 옵션을 누르시면 돼요.
survey operations in the harbor,
Believe me.
close to the shore, and not only to the shore, and also at sea. And in addition, we can use any platform of opportunity to conduct like mine countermeasures operations. This project started a while ago in 2005. Now in peacetime we conduct survey operations to check our territorial waters, to survey harbors and close vicinity of the shore. We deployed the system in this year in historical ordnance disposal operation. It's Open Spirit. And the last one, Squadex in Lithuania, and it showed very good results. The contacts which were found were exactly on the position, so we are happy with the performance of the equipment. Actually, we cannot compare this system with the PAP because PAP is a remotely operated vehicle. It's connected with a cable. This one is different. It is autonomous. You can deploy it from anywhere. We can deploy it from the rib, from the ship. The weight is small, 70 kilos, and you can operate it easily with two men. The generation of sonar is new, and the view, the picture, what we get is also very good.
Discussion topic is as follows. As mentioned in previous slide, the use of UUV in military field will increase. Then due to the UUV, how do you guys expect future maritime battle to change compared to the past? Please feel free to give us any opinion.
Maybe different from wars, like I don't know, I hope it doesn't happen, but if there is a big war from here, maybe when fully automated UUV unmanned vehicles are available, I think war would be, at least the first line of war would be a proxy war. So previously war is like when soldiers come to somewhere and fight, or like with a vehicle, like them being present at that place. But now, because they don't have to be present to fight, there will only be machines, and maybe machines will be fighting at first, like machines with each other without human presence, and maybe remotely controlling them, or the machines being fully automated. So the first line of war would be maybe proxy war. And then after that, like if one or more side wins, or then it would go to a point where the human beings would start fighting. So that's what I think will happen maybe in the future wars.
I agree with Barakat. I think the advent of new autonomous weaponry, for example, UAV, in the future war, the focus will be more about hitting strategic military or economic points rather than killing people. So I think for that, so for example, if a country wants to, like, for example, if a country wants to destroy the oil infrastructure of another country, it can use small UUVs to strategically go and precisely attack their offshore oil fields or something like that. So I think future wars will be mostly based on hitting the opponent's economy, and I think UUV will like UUV and even AUV will be will play an important role in that.
I also agree with Adib and Burkett's idea that proxy war, and because of proxy war, it might be some weird idea, but because of proxy war, the environment can be more destroyed, because when the war in proxy war is in ocean, then the UUVs can be destroyed in ocean, and it maybe can be ocean garbage, because getting a machine out of water isn't important as saving people. So it's likely that garbage will accumulate.
Yes, and I agree with this idea that the world should be ended the proxy war and not be a big thermonuclear war, because I believe that the UUV is the ultimate solution for the nuclear submarine, because the nuclear submarines is the best the limitation of its operating time is human, so the removing human from the nuclear submarine can be ultimate nuclear missile launcher for in the ocean. So it may it's same with the Cold War period. It will prevent the large war to go into the thermonuclear war.
Yes. Is there any extra?
Maybe I don't know, but no, when I think about it, maybe it may be more destructive than the war, the past or present forms of war, because say when you think about, for example, World War II, during the World War II, the war was happening in Europe mostly. So at that time, say if you think when Germany at the end was invaded, the troops were coming from Russia and also France and UK. At the time, like people were coming to after say Germany was lost the war. But if you think about it now, if say machines were coming, I think it would be inhumane and maybe like kill more people and destruct more properties, because they are not human being and they won't have any sense of humanity, and it's just people controlling remotely, or at least, I mean, if it's fully automated, it's going to be fully machines controlling itself. So I think it would be there would be more catastrophe, not just for maritime war, also any form of war where automated machines are involved. There will be more loss of life and more destruction. I think it would be much more catastrophic than the forms of war now.
Barakat made a very good point. I recently read this book called 21 Lessons for the 21st Century by an Israeli writer, Yuval Noah Harari. And in that book, he was exploring the ideas about unmanned vehicle and warfare. And one thing he mentioned was that for previous kind of maritime war, there were people inside the ship running the weaponries, right? So sometimes humanity can strike in, and there are cases where soldiers decided to disobey their superior and form a mutiny because they did not want to kill more. But if we have unmanned vehicle, which does not have that sense of humanity. If it is programmed to kill people mercilessly, then it can cause more casualties, as Barry mentioned.
I have an idea about that killing human also. In my case, it may be some optimistic idea, but I think that UUV will not be programmed to kill just normal people. So I think they will kill just soldiers. So unlike the past wars, the soldiers can kill the normal people, or that kind of catastrophes are existed in past days, but in the future wars, just for the machine versus machine or soldier versus soldier, that kind of war can be increased.
Okay, that's it. Thank you for you guys' passionate discussion. This discussion is
Thank you.
over.
All right. Thank you for your discussion. Nice discussion. Okay, can you unshare your screen, please? Yes. Then I can show you the second part of lecture. Because we don't have enough time, so I can start, but we may stop during the second part of the lecture and continue on next week. All right, this is the second part. And we are covering the underwater system. And I will show you the unmanned underwater system, ROV and AUV. We just have a discussion on this. Good discussion. Right? So unmanned underwater system is ROV, AUV, and hybrid. The main difference can be tethering the cable to the parent ship or untethering, no cable. Right? So the other thing is very similar.
Excuse me, Professor, your screen is not sharing.
My screen is unshared, not shared.
Yes.
Oh, okay, sorry. I need to share first. Sorry. Okay. So, and you see that free swimming probably similar, probably more on AUV, right? And propeller should be used for both of them. One difference is glider. Underwater glider is usually for AUV because glider covers more wider area than AUV, and also more on ROV. So coverage range is smallest for ROV, and then more wider for AUV, but glider covers more wide because it uses less energy than AUV. The other thing is very similar. So degree of autonomy, so there is a full autonomy and semi-autonomy and teleoperation and remote control. Very similar wording. You see that semi-autonomy is there is a human and there is a interaction, but that interaction is a very small, a higher level communication rather than detailed interactions. So that teleoperation, there is also interaction, but there is a incremental goals. So we call this is a task level, sub-task level. But remote control, there is no sensory feedback, such as video, image feedback. Video is also kind of a sensor. We call this is a vision sensor. Usually, remote control, there is no sensor. But there should be sensor, but sometimes there are limited sensors. So that so level of interaction or control by human is high level at the remote control, but very little small level, little communication, little action control by semi-autonomous, and for autonomous there is no control, human control. The mission is given, then this is very similar to human body. And autonomy again, in old days, first generation and second generation and third generation. So in the middle now is that you see that there is an intervention by human, and it is task-based rather than full control, low-level control by human. So sub-task is given to the EUV, and also there is a agent system. In old days, it is single agent, but there can be a multi-agent system. You see that one human can operate multiple EUVs, so it can work as a team. There's several EUV systems work as a team, rather than single operator and single system. All right, and then the difference is once again, AUV is used for survey and exploration for the wider range of area, so inspection something. But ROV, as we have a discussion, it is used for construction, installation, and repair and maintenance and welding something. So industrial working should be until used by ROV. Why? Because of the power level, the force, the energy power level. If the construction, installation, welding should be use high power, but AUV support power is only battery. But ROV can provide high power using cable. So that is the reason why the ROV can be used for industrial missions. Power consumption, that is the most important difference. And then what? Missions. So we already discussed the industrial missions, which requires high level of power, and scientific mission, that is for survey or exploration, and military missions. Military missions can be divided into different parts. Which one? Sometimes it requires a high level of power or high weight, or sometimes it can be a very small one and untouched, detected by enemy. In that case, you need to have a very small size of unmanned vehicle. Also, they don't need to return back. Only mission can be satisfied, they can be lost. Right? So it can be further reduced the size because energy level, the battery size can be smaller. So there are different missions and different kind of mixture. Right, for the industrial missions, there is oil and gas field development, CO2 storage, renewable energy, and also construction. Construction can be this kind of grabbing and discovering So that requires a big energy source. So you need a cable. So underwater working, and also some installation and scientific missions, oceanographic research, environmental monitoring, and bathymetric survey is very deep water. So long distance, say 30 kilometers down to the water, deep water, or 10 kilometers down. Ocean archaeology, the survey. So they need to coverage a very wide area, so that the cable is not convenient to has a long cables, so that AUV can be used for this. One more slide. Military missions. Intelligence is most important. Right? Surveillance and reconnaissance. So detection. So anti-submarine warfare is used for such a torpedo. Torpedo is kind of a AUV, right? Torpedo itself, you can say that this is a very AUV, unmanned vehicle, right, with battery powered. So if you use AI for the torpedo, then it can be very smart, so that the capacity can be higher with the torpedo. And minefield operation. All right, so let me see. One more slide, and then we can stop. Power source for the vehicles, the surface powered, it is for ROV. So parent ship, they has a tether cable. So its source is from surface to the vehicle. And self-powered, you need to have a battery or fuel cell or something like that. And there is also a hybrid system. Sometimes there is an idea that there is a docking system and underwater docking system. So because AUB need a battery refueling or exchange of battery, but the depth of the water is very high. So traveling distance for the surface ship returning back to the base, it takes also time. So that in deep water, say 10,000 meter something, or 6,000 meter, there is a satellite of a refueling station, gas station, something. So that the AUV is docking once the battery is low. It is very similar to something like vacuum cleaning robots inside our room. There is a commercial small robot cleaner, which is running automatically, unmanned robot that clean up vacuuming the room of the apartment. But once the batteries are low, then the robot cleaner is returning back to the base station, that they can be recharging the battery. That idea is very similar to the hybrid system using remote refueling docking system. All right, that's enough for today. There is one question. Oh, this is not question. So that we can have any other questions? Schedule or anything? No? Then we can stop the class today and see you next week. Right? Bye now.
Thank you, Professor.